Hello everyone. Welcome to part 6 of a lecture series of numerical matrix methods for solving the system of linear algebraic equations. In this video, I'm going to solve a simple example of a 3 cross 3 matrix using Gauss Seidel method. If you notice a peculiar thing here, that the coefficients of the variables x, y, z are bigger than the previous examples, and therefore it is advisable that we use Gauss Seidel iterative method. Although we can use other methods also, but I think they can take more time to solve. So we use a simple iterative method that is called as Gauss Seidel method. Okay, so what we do is, as I have already explained to you in the previous video, we are going to rewrite this system as for equation of x, y, and z. And how am I going to do that? The selection of equation depends upon the coefficient of x. So we have, if the equations are not arranged in the descending order of the coefficient of x, we are first supposed to arrange them in the descending order of coefficient of x. And you can see here that this coefficient is the highest, and then this and this. So now we have arranged, the equations are already arranged. Now we can write them in this form. So I would like you to pause the video and see how these equations are written. So let me just explain the first one. I take 6y and z to this side, to RHS, and then divide the entire expression by the coefficient of x, that is 27. So I get this equation. In a similar way, I get the equation of y from the second equation and equation of z from the third equation. Okay, so we start our iteration now. So as explained earlier, we are supposed to start with the initial values as 0, 0, 0, and I'm denoting the initial values of x, y, z as x0, y0, and z0. So what do we get? So we first calculate x1. So x1 from the previous equation, I'm going to replace y and z as y0, z0, and since the values of y0, z0 are given as 0, I get 85 by 7, that is 3.5 as my answer for x1. Then I calculate y1. So when I calculate y1, um, now you can see that in the instead of x0, I am using the value x1. So as explained earlier, we are supposed to use the new value of x, y, z as soon as they are calculated. Therefore, I'm using x1 here. Now here I'm using z0. Why? Because z0 is the value which we know for z, and we haven't calculated any new value for z. Okay, so after the substitution of all these values, I get this answer for y1. So similarly, I can calculate z1. Uh, so you can see that the values now of x0 and y0 have been changed to x1 and y1. So when I substitute this value, I get the final value of z1 as 1.91. Before we start with the next iteration, let me remind you, since Gauss Seidel method is an iterative method, uh, we need to know how many iterations we are going to perform. That depends on the values of x1, y1, z1. And one more question is, when do we stop iterating? So for that, we need to see that we should have two consecutive iteration in which the values of x1, y1, z1 are exactly same up to 4 decimal places. In this example, although I'm taking only 2 decimal places, but as far as possible, please keep your answer up to 4 decimal places. So try to keep on iterating till you get the two consecutive iterations of the same value of x, y, and z. Okay, now let us go to iteration 2. I have already calculated all the values here. You can see here I am using the new values of x now for iteration 2, x, y, z, that is x1, y1, and z1, which we are obtained from iteration 1. So now we calculate the new values of x, y, z, that is x2, y2, z2, and then you can see that I have already calculated and I got these values. I want you to pause the video and actually perform this all the calculations and see if these answers are correct. So once you do that, now let me go to iteration 3 now. So now iteration 3, I start with the initial values of xyz which are obtained in the previous iteration, that is iteration 2. And then after the calculation, I'm not going to show you the calculations now. Directly I'm going to write down the answers. So I get these answers x3, y3, z3 as the same values as of iteration 2. So this is the time when you stop iterating, and finally this is your solution. Okay, now so what I want you to do now is go to this Moodle link with the user ID and password mentioned here. There will be many practice examples, quizzes, and Scilab codes which you can use to validate your answers. I mean that whenever you solve these examples manually using some methods, you can check whether the answers you got are correct or wrong using the Scilab codes. So please feel free and visit this Moodle site. If you have any queries, you can either discuss in the blog that I will be posting on Moodle, or you can contact me by email. My contact details will be available on Moodle. That's all for today. Thank you.